Hello everyone, welcome to my YouTube channel Easy Way to Learn. I am Shailja Tripathi and today's topic of discussion is carbon and its compound. So let's get started, remain focused and follow the lecture. See, carbon is studied under a separate branch of chemistry which is called organic chemistry, and it has been placed separately because of its immense importance in our daily life. So you have food, clothing, medicines, books, they are all made up of carbon compounds. Even our body, plant body, it's also made up of carbon compounds, like cell wall is made up of cellulose, and a photosynthetic product is glucose, that is also a carbon compound. So life on earth itself is carbon based, so its importance is very much. But in nature, carbon is present in very small quantity. Like in the earth's crust, it is present as minerals only 0.02% in the form of minerals. And in atmosphere, it is present as carbon dioxide. Percentage is again very small, 0.03%. Though its percentage in nature is very less, but its importance is immense. So first we will see few of what are the properties of carbon compound. Then we will study in detail why it shows such a property. So let's see. Most carbon compounds are poor conductor of electricity. If something is a poor conductor, that means there are no ions to conduct electricity. So these compounds do not give rise to ions. They have low melting point and boiling point. They are usually liquid or gases, insoluble in water but soluble in organic solvents like alcohol, then kerosene, then carbon tetrachloride, these are few of the organic solvents. Okay, one more important thing, our fossil fuel, fossil gases are also carbon based. So you can now feel how much it is of relevance. Now we'll see what is the atomic number and what is the electronic distribution of carbon element. The atomic number of carbon is 6. So by now you must be knowing how to write down the electronic configuration, which was part of class 9 syllabus. Atomic number of carbon is 6. So its electronic configuration means arrangement of electrons in the atom. So K and L shell, electrons are arranged 2 and 4. That is its valence shell. L is the valence shell. Valence means outermost shell. So L is called valence shell, and the electrons present in the valence shell are called valence electron. Valence electrons. It is these valence electrons that they participate in a reaction. That is, these electrons can move in and out of the atom. So there are 4 valence electrons, and to achieve its nearest noble gas configuration, what do the atoms do? They either take electrons from outside or they give their electrons. So reactivity of element depends on its combining capacity. That is, to achieve this noble gas configuration, how many electrons it is exchanging. So you can write reactivity of element is explained as their tendency to attain completely filled outer shell. That is noble gas configuration. So we shall see now how carbon will achieve noble gas configuration. That is, the outermost shell should have 8 electrons. So let's see how it does. See, elements react either by giving the electrons or by taking the electrons. Elements can react in two ways. One of the ways is by complete transfers of electrons that you studied in metals and non-metals, and that leads to formation of ionic compound or the electrovalent compounds. So first way is complete transfer of electron. Complete transfer of electron. This you studied in metals and non-metals, but I'll briefly explain it here also. See, for example, if we take metals, so metals are those substances which lose electron. So metals always lose electron, or they give up their electron. Lose electrons to attain noble gas configuration. To attain, or you can write to attain stability. For example, sodium configuration is 281. Its atomic number is 11. So to attain noble gas configuration, it will give away its one electron. There will be, see, metals always lose electron to gain stability. So here the configuration is 2,8. And if we see non-metals, they always gain electron. So metals, I'll write it here, non-metals. They are substances or the elements which always gain electron. So these two definitions are on the basis of electrons. So non-metals always gain electron to attain stability. Like chlorine, atomic number is 17, electronic configuration is 287. So chlorine will gain one electron, or it will add one electron to its outermost shell. Hence, it will form an anion 288. So this negatively charged particle is anion. So this way metals lose electron and non-metals gain electron, and by their interaction the compound that is formed is called ionic compound. So if we see the overall reaction, the sodium plus electron, it is losing one electron, whereas chlorine atom is gaining one electron. So the electron lost from sodium is gained by the chlorine atom. So there is interaction and the compound that is formed is sodium chloride. So it will result in the formation of NaCl, because interaction takes place because of exchange of electrons. So the electron lost by the sodium will be gained by chlorine atom. So this exchange of electron result in the formation of sodium chloride, and this sodium chloride will be called ionic compound or electrovalent compound. So definition will be that compounds that are formed by complete transfer of electrons. So these compounds result when dissolved in water, they are soluble in water. When they are dissolved, they will result in the formation of ions, and thus they are good conductor of electricity. So this is one way of interaction, that is transfer of electrons. Another way of transfer is by sharing electrons. So we'll see the other way. This is the first way, and other way is sharing of electrons. This is another way of combining. So carbon compounds carbon compounds are formed by sharing of electrons, and hence they are called covalent compounds. Covalent compounds. So carbon compounds are covalent compounds. Now we'll see why this process of sharing is taking place in carbon and not complete transfer. So I'll explain that point. Let's once again see the atomic number of carbon. Atomic number 6, and its configuration is electronic configuration is 2,4. Now there are two possibilities to attain stability. It can either lose 4 electrons or gain 4 electrons. See, there are two ways of attaining a stability. Or I can write down this format. Carbon can attain stability two ways, and these two ways are very much explained in the book, in your NCERT book. See, it can either gain 4 electrons and form C4 negative anion. Let's see what will happen. See, this is carbon having protons 6 and electrons 6. Okay. See, carbon has 6 protons and 6 electrons. So it is balanced. Hence, the carbon atom is stable. But once it forms anion, C4 negative anion, the number of protons will not change, but number of electrons now will be 10. So, and you already know that protons are present in the nucleus, so their number does not change. Whatever is gained or lost is from the outermost shell. So 4 electrons are added to the outermost L shell. So total number of electrons now are 10. 6 plus 4, 10. This anion will not be stable. Not stable. Why? Because it will be difficult for 6 protons to hold on to 10 electrons. So 6 protons cannot hold on to 10 electrons. There are too many electrons. So hence C4 anion is never formed. Not stable as it is difficult for 6 protons I'll write it here as it is difficult for 6 protons to hold on to 10 electrons. Hence, C4 negative anion will not be formed. Now, let's see another situation where it will lose 4 electrons. See, here it is gaining 4 electrons, and if it loses 4 electrons, if it will lose 4 electrons, then it will attain noble gas configuration of helium 2. Okay, let's see. Carbon has 6 protons, 6 electrons balanced, and the atom is stable. The moment it loses 4 electrons, it will form a cation. Again, number of protons will not change, but number of electrons are reduced to 2. And you must understand, again, it is not stable because it is difficult to remove 4 electrons from the shell, because the electrons are not lost, or I can say they are not lost together, but they are lost one by one. That is, one electron will come out, then next, then next. So the energy required to remove first electron then will be comparatively less. Then the energy required to remove the second electron. Then energy required to remove third electron will be much higher. So to remove 4 electrons, too much energy will be required because electrons are lost one by one. So every time energy requirement will increase. Hence, formation of C4 cation will require a lot of energy. Again, this possibility is also not happening. So this is also not stable. Not stable since lot of energy will be needed to remove 4 electrons. Hence, we can say carbon will neither form an anion or a cation. So, it will neither gain electron nor lose electron. So, what will it do? It will share the electrons. So, another possibility is sharing of electron to attain this noble gas configuration. Sharing of electrons. Now we'll look into some compounds which are formed by sharing of electrons. Okay, now let's see few of the compounds that you have to study. So let's look at simple molecules. Formed by sharing of electron. First, we will see few diatomic molecules or by a cross. So, this will be called a dot diagram, dot electron dot diagram. See, only the outermost electron will be shown in the diagram. So, hydrogen is having only one electron. So, you put one dot here. Another atom will also have one electron. So, this hydrogen will share this electron of another atom. So, now it has 2 electrons. So, it has attained its nearest noble gas configuration resembling helium. So, the electron, this pair of shared electrons, this is shared pair. It's called shared pair. And it is represented as a single line. So, one single line means one bond and that is formed by 2 electrons. A pair of electrons will form a single bond. Okay, now let's see another molecule, that is chlorine, Cl2. Cl2. See, chlorine has the electronic configuration 287. So you can write 287. Remember the atomic numbers. If you haven't learned it, learn it. Find out a way to learn. Or if you are finding it difficult, then you write in the comment box. I'll see that you get some trick to learn atomic numbers from 1 to 20. That must be thorough with you. See, chlorine, again in the electron dot diagram, you will show only 7 outermost electrons, and one must always remember that electrons are always shown in pair. So, how you will arrange? 2, 2, 4, 5, 6 and 1, 7. This is the manner in which it is shown. Again, 2, 2, 4, 5, 6 and 1, 7. You can put a cross or a dot, whatever you like. So, it will attain configuration of 8 electrons in the outermost shell by sharing 1 electron from this chlorine atom. Similarly, this chlorine will also attain stability by sharing the electron of another chlorine atom. So, these two are shared pair of electrons, and those not participating in bonding are called lone pairs. So, these are lone pairs. not participating in bonding. They do not participate in bonding. Okay. Again, it can be represented as chlorine, one single bond. So these two electrons will form one single bond. The oxygen, its atomic number is 8 and electronic distribution is 2, 6. So in electron dot diagram, we will show here 6 valence electrons. See, oxygen 2, 2, 4, 5, 6. It will share electron with another atom of oxygen. So this atom completes its octet by sharing, and this atom also completes its octet by sharing. So in the shared region, we get total 2 pairs of electrons. So there are 2 pairs of shared electrons, 2 pairs of shared electrons, and 2 pairs of lone electrons. Lone electrons mean that are not participating in bonding. So each atom has 2 pairs of lone electrons, and this can be represented as oxygen, and 2 pair means you have double bond. One line indicates pair of electrons. So 2 line indicates 2 pair of electrons. So next molecule will be nitrogen. Again, atomic number 7. It's a diatomic gas present in nature. Atomic number of nitrogen is 7. So its electronic configuration 2, 5. So the outermost shell or the valence shell has 5 electrons. Let's arrange it. See, the arrangement is like this because there are 5 electrons, so it needs 3 more electrons from another atom for sharing. So it will complete its octet 5, 6, 7, 8, and this way. So it is represented as triple bond. See, 2 electrons are forming one single bond. So we have 3 pairs of electron in the shared region which are forming the bond, and 1 pair of lone electron. So this is single pair or 1 pair of lone electron, and this is 3 pairs are shared. 3 pairs of shared electrons. So you have to draw electron dot diagram in this manner. Next we'll take another simple molecule, that is water. See, we have to actually draw electron dot diagram of water, ammonia, methane. These are few of the simple molecules that are mentioned in your book. Carbon dioxide, then S8. Okay, so these are the molecules which you have to prepare. Okay, let's start with water. See, there are total 3 atoms The least number is oxygen. It is just one atom. So it will be placed in the center and hydrogen will be placed on either side. So this will be the rule for all the molecules. The one with the least number will be placed in the center and the other atoms with more number will be placed around that central atom. So oxygen will be the central atom and hydrogen will be on its either side. So let's arrange again. In case of oxygen, electronic configuration you must be thorough, 2, 6, and in case of hydrogen it has just one shell, one electron. So let's place 2, 2, 4, 5 and 6 electrons of oxygen, and electron of hydrogen is denoted by a dot just to separate it from oxygen. Let's see. Hydrogen will complete its octet. Sorry, duplet, not octet, duplet. Hydrogen gets stability by acquiring 2 electrons. So it completes its duplet, while oxygen completes its octet. So it is represented like this: oxygen, hydrogen, hydrogen. This is representing single bond. Here it is representing single bond. So oxygen is combining with hydrogen on the either side. Okay, we do not make the molecule like this. There is a reason to it. I'll explain it here. We bend this angle, or we make an angle, not 180 degree. Reason being, there are 2 lone pairs and these 2 lone pairs create repulsion. So the bond slightly bends. So these electrons are basically electron clouds. See, electrons are present as clouds. So there will be cloud. Similarly, downward there will be cloud, means above and below the plane. So if we see, for simplicity I am just drawing the upper part. See, there will be repulsion because electrons will repel each other, and there will be repulsion between lone pair and also the shared pair of electrons. So this repulsion causes the hydrogen bonds to bend, so it will form an angle. Now you have to just remember that when you are writing, you have to make this bond slightly at an angle, not 180 degree. That's it. And you can show lone pair of electron here, which are the cause for this bending. Okay, next is carbon dioxide. Methane, I'll take it later. See, carbon, again its atomic number is 6, electronic configuration 2, 4, oxygen 8, electronic configuration 2, 6. So carbon will be the central atom, and on either side you will place oxygen atom. Carbon has 4 electrons in its valence shell, and oxygen needs 2 electrons to complete its octet. We arrange electrons of carbon, that is these 4 electrons, and oxygen electron. 2, 2, 4, 5, 6. The carbon will complete the octet like this. It has 8 electrons. See, now the octet is complete. It is represented carbon, double bond oxygen, double bond oxygen. Double bond because two bonds are being formed on either side of. So carbon is a tetravalent molecule. Carbon dioxide, carbon is a tetravalent because it is having 4 valence electrons. So it is taking 2 electrons on the either side from oxygen. Okay, now this angle is 180 degree. This is a linear molecule. You can write in a straight line because there are no shared lone pair of electrons present to produce repulsion. So this is a linear molecule and you can draw it in a straight line without any bending here. Okay, let's take methane. So it is linear because you can write the reason because there are no lone pairs to cause repulsion. Next is methane from oxygen. Okay, now this angle is 180 degree. This is a linear molecule. You can write in a straight line because there are no shared lone pair of electrons present to produce repulsion. So this is a linear molecule and you can draw it in a straight line without any bending here. Okay, let's take methane. So it is linear because you can write the reason because there are no lone pairs to cause repulsion. Next is methane. Okay, this is one of the simplest carbon compound, CH4. It is called methane or marsh gas. Produced as a result of anaerobic respiration in stagnant water, where something is dying. Okay, so methane, again carbon 6, write the configuration 2, 4 and hydrogen, its K shell will have only 1 electron. So methane basically is a simplest carbon molecule. It is also called marsh gas. Basically this is produced due to anaerobic respiration in stagnant water, where something is decaying. So you can write carbon will be the central atom. So its electrons are arranged in this manner. Then hydrogen with 1 electron each. You need to practice a lot. If you are not thorough, then please practice it before your exam. So hydrogen is completing its duplet and carbon is completing its octet. Next molecule is ammonia. Ammonia is left. nitrogen, atomic number 7, configuration is 2, 5, hydrogen, 1 electron. Now let's arrange. Three hydrogen, so now nitrogen has one lone pair that which is not participating in bonding, that is one lone pair, and three shared pair of electrons that are participating. So you can write this as N, H, H, N, and a lone pair. Again, these bonds are drawn at an angle just because this lone pair is again, it's a cloud of electron which is causing repulsion between these two and these two. So the angle will be slightly decreased than 180 degrees. You need not remember the angle, but while drawing, make sure that these angles are little bit bent. So this is ammonia molecule. Ammonia is a highly soluble gas. It is highly soluble in water. Last, we have to draw S8. It's a polyatomic molecule. See, sulfur 16, so its configuration is KLm286. So its outermost shell will contain 6 electrons. So let's see, first we arrange 8 atoms are arranged in this manner, circular manner. This I have drawn just for simplicity's sake, that you must learn how to make the electron dot diagram for S8. See, now the 6 electrons will be arranged in this manner. See, 2 will not participate in bonding, so they will be lone pair, and rest 2 will occupy the shared region. Sorry, place it X. So for this atom, 2 pairs are not participating in bonding, and 1 electron each is placed in the shared region. So you fill the rest of the atom in the similar manner. Place the electrons in the similar manner. This, and complete it.